Okay, so now we're going to look at how we simplify these. Well, in order to simplify these, we need to switch into its exponential form. Okay? So I'm thinking here, log base 7 of 49 equals something, right? So I'm going to add an equals something. So I'm going to switch to exponential form. So when I switch to exponential form, I'm thinking 7 to what power gives me 49. So then I'm going to think of what my powers are for 7. So 7 to the first is 7, 7 to the second is 49. Aha, look. So we got the 49, so our question mark is 2. So we're switching the forms to determine what our exponent is to the log. Now remember, our exponent or answer to the log is. Now remember, answers to logs are exponents. Okay, so that's why this exponent of 2 is the answer to our log. Okay, if we look at this one, we have log base, oh, I'm not writing it in log again. Log base 12 of 12, so I'm doing 12. You can set it to variables as well. So 12 to the x power equals 12. Okay, well, again, if we start our powers of 12, 12 to the first is 12. Well, we wanted 12, so our x value is 1. Okay. Now, this one might be a little bit trickier. So we're thinking 4 to the y equals 1/64. Again, it's not mattering if I use a question mark, an x, a y. The variable that you're using, setting it equal to here, doesn't matter. Okay. Now, if I think of 1/64, if I think of my powers of 4, I have 4 to the first is 4, 4 squared is 16, 4 cubed is 64. So I can say, okay, well, this is 1 over 4 cubed. But you should remember that if it's in the denominator, you can move it to the numerator and make it a negative exponent. Okay, we had this rule that if you had x to the negative a, that's the same thing as 1 over x to the a. And if you had 1 over x to the negative a, that's the same thing as x to the a. Okay? So you move, when you have a negative exponent, you move it from the bottom to the top or from the top to the bottom, and then you change the sign of the exponent to be positive. So that means here I can really change this to be 4 to the y equals 4 to the negative 3. Well, then we've got here that our y value is negative 3. So our exponent is negative 3 that gets us to 1/64. Okay. So try this one on your own, pause the video, and then come back and take a look at it. Again, it's important that you're checking to see if you know how to do this and not just following along. Okay, so we would do 2 to some power equals 64. So I've got 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth, oh, finally, 64, right? So we had to go a little bit further on this one to figure it out. So 2 to the 6th is 64, so our answer is 6. Okay. So now, if we look at our next one, okay, this one we're thinking, okay, 3 to some power equals negative 12. Okay. Well, this is a little bit weird because we don't have, if I check my powers of 3, 3 to the first equals 3, 3 to the second equals 9, 3 to the third equals 27. So 12 is somewhere in between 9 and 27, but it's also negative. Okay, well, we had done whole numbers, so maybe let's try like a fraction number. So if I do 3 to the 2/3, okay? So if we do 3 to the 2/3, if you remember, our fractional powers mean that it's a cube root of 3 squared. Well, 3 squared is 3 times 3, which means that there's nothing to pull out, so then this is as simple as it gets. So that doesn't give us a negative, so maybe let's try a decimal. So if we do 3 to the 0.5, so I'm just going to use my calculator to do 3 to the 0.5. So that gives me 1.73. Okay, well, that also doesn't give me a negative. So I'm looking at different kinds of numbers. So we did a fraction, we did a decimal. Oh, let's try a negative exponent. So if I do 3 to the negative 2. Okay. Well, remember our negative exponent means that it moves it to the denominator. So then this just turns into 1 over 3 squared, which is really 1/9. Well, that doesn't make it negative either, right? So maybe we could try like 2 a root. So like 3 to the square root of 2. So I'm just going to use my calculator. So if we do 3 to the square root of 2, I get 4.729, which doesn't get us to negative. Okay, so we've tried a whole bunch of different kinds of numbers, and the reason that none of them are working is because this is not possible, right? Okay, so I'm going to erase all this so that we can write. Okay. Log of a negative number is not possible because you can't raise something to a power and get a negative. Log of a negative number is not possible. Okay. So this is an important detail to remember. If we do the natural log of e, well, hopefully you remember from how we were switching that those are inverses of each other, so these undo each other. If I switch forms, natural log has a base of e, so I would do e to the y equals e. Okay, well, e to the y equals e, that means that if I check my powers of e to the first is e. So that means that our y would have to be 1. Or if you're thinking in terms of inverses, these undo each other, so it just leaves you with 1. Okay? Either way, that happens. Now notice we had that same property here when the base and the log matched. So we've got this rule that log base b of b is just 1. And that works for any base, whether it be natural log or some other whole number like 12. Log base b of b will always be 1. Okay. If we look at this next one, we have natural log of 1. Okay, well, if we say e to the x equals 1, well, if we do e to the 1, that's e, and then we're just going to be getting higher than that, so let's go backwards. So e to the 0. Now, if you don't remember, anything to the 0 power is 1. So this means here that this is equaling 0. Because any power to the 0 is 1. Okay. So if we look at this one, then we have 4 to some power equals 1. Well, again, if we start 4 to the first, that's 4. 4 to the second, that's 16. So I need to go the other direction. So 4 to the 0 is 1. Okay, so anything to the 0 power is 1. So notice we have, if you have log or natural log and of where the argument is 1, that will always give you 0. So log base b of 1 is always 0. That's because b to the 0 is 1. Okay. Try this one, see what you come up with, pause the video, and then come back and check and see if you got it correct. Okay, so we're going to look at our powers of 7. So I'm going to do 7 to the x equals 1 over 343. So I do 7 to the first is 7, 7 to the second is 49, and then 7 cubed, you have to use my calculator because I don't have that memorized, is conveniently 343. So that means that this is really 1 over 7 cubed. Well, I can move this 7 cubed that's in the denominator to the numerator if I make the exponent negative. So I can do 7 to the x equals 7 to the negative 3, and then that means that our x is negative 3. Okay. So we get our exponent is negative 3 because we had a fraction. Okay. Now, there are some numbers that won't work, right, that are not nice. So if we try and simplify this number, 5 to the x equals 255. So if we check our powers of 5, so 5 to the first is 5, 5 to the second is 25, 5 to the third is 125, and then 5 to the fourth is 625. Well, it's somewhere between 3 and 4, right? Because 255 is in between 125 and 625. So I could start guessing, right, and checking. So I could do 5 to the 3.2. That gives me 172. So I need a little higher. So 3.3 gives me 202. So 3.4. And then I can just keep guessing. So 3.4 was 237, but 3.5 is 279. So it's somewhere between 3.4 and 3.5. So then I could say, okay, well, maybe it's 3.42. So if I try 5 to the 3.42, then I get 245. So I'm going to go a little higher. So I did 245 or 3.45, and that gave me 257. So I'm going to try 3.44, which is 253. So I can keep doing this, but this obviously is really annoying to guess and check in this manner. So what happens is that there's a way that we can put this in the calculator, and the calculator can calculate what the number is instead of us doing this guessing and checking plan, okay, which is much more efficient. Okay. The pattern that we use is this. Okay. So to put this into the calculator, we use what we call the change of base formula. So if we do log base b of x, that's the same thing as log x of log b. The way that I remember this is that the base goes in the bottom. Okay. The base going in the bottom, that alliterates, so you start with the same letter, so that helps me remember. Okay. So when I go to put this in a calculator, this is really log 255 divided by log 5. Okay. So on your calculators, you can do, so if you're using a Desmos calculator, you would go to function, and then there's log. So then you would go back to main to do 255. You would have to close your parenthesis, then do divide, then go back to your log on the function page, and then do log 5. So it gives us 3.442980622, and we'll keep going. Okay. Now, if you are on and that would work for all calculators. If you're on your TI calculator, you can do log is left of number 7. So you would do log 255, close your parenthesis, divided by, again, log is left of number 7, log of 5. Okay. Now, there is a way on some of your TI calculators to do where make it look like your paper. So if you go to math and then you go up, you can go down, but it's a lot more buttons, so I like to go up to letter A, which is log base. Then notice it will make it look like your paper. So I would do log base 5 and then over to do 255, and that would give me my 3.44298, so on and so forth. Okay. And then if you're on Desmos, the graphing calculator, I believe, I feel like there's a math log base somewhere. I think it's on the graphing calculator. Functions. Yeah, there we go. So if you do the graphing Desmos calculator, you can go under functions and then miscellaneous, and then it's on the middle column, second from the bottom, and then you can do log base 5 over of 255. Whoops. Didn't go over enough, 255. And then it will look like your paper, but there's not, at least I haven't found it on the scientific calculator of Desmos. Okay, so that's how you can use your calculators to get to the value. So 3.443. Oops. Oh, we wanted to round to the nearest 10,000ths. Your 10,000ths, you do tenths, hundredths, thousandths, 10,000ths. So that's 4 decimals. So let's go back. 3.4429. After the 9's and 8, that means that will bump it up. So it's 3.443. So 3.443. Okay. So again, here, this would be log of the argument divided by log of the base, because the base goes in the bottom. So I do log of 1/300. Yes. And then over, and then you have to close your parenthesis. If you don't close that parenthesis, you will get the wrong answer. So make sure you close that parenthesis. Log of 6. This parenthesis you don't have to close because it's the end, so it will automatically close it. But the one on top, you were doing something else, so you had to make sure to close it. So you get negative 3.1833. So after the 3 is a 4, so I keep it the same, so negative 3.1833. Okay. So pause the video, practice these next two, and then come back to make sure that you got it right. Okay, again, it's important that you're checking your calculator skills and not just saying, I know how to do this. So let's try on the TI calculator now. So we're going to do log of, forgot the numbers already, 1 over 426. Close my parenthesis, divided by log 4, 1/4. And then hit enter. Right? Again, you could do math up to log base and then do 1/4 over 1 divided by 426 and get the same thing. So after the 4 decimals is a 5, so that bumps it up. So 4.3674. 4.3674. Okay. And if we do log base 1/3 of 200, that'll be log 200 divided by log 1/3. So log 200 divided by log 1/3. That gives us negative 4.8227 after the 7's a 3. Negative 4.8277. Okay. Now, on this one, remember that our base is an unsaid 10, which means that this would be log 65 divided by log 10. However, our calculators are in base 10, so I don't actually need to do this. I just literally need to make my screen look like this on my calculator. So we have log 65, so I would just hit the log button and then 65, and then close my parentheses. So 1.8129. Seriously, 8129. Okay, good. Now on this one, this is the natural log of 729. You have a natural log button on your calculator. So on your TI calculator, your natural log button is left of number 4. So you do left of number 4 is the LN, so you do 729, and again, you're literally just going to look on your calculator like it is on the paper. So you get 6.5917, assuming I remember the correct number. If you do it on Desmos, if you go to function, left of log is natural log. So it's on the 3rd row down, and then it's the 3rd one from the right. So you do natural log of, and then you have to go back to main to get to your numbers, so of 729. So 6.5917, because after the 6 is a 7, so it bumps it up. So 5917. Whoops. Now, you can always check that. If I were to do e to this power, so if we go, oh, I had done it on this one. If I do e to the, and then I use my answer, that gives us our 729. So you can go back and forth and just double check your answers if you would like. But that's how you put it into the calculator. So you have to remember this or use the math log base to help you get to your answer. If it's log base 10, that's what your calculators are in. So you just need to make it look like the screen. You also have a natural, or like your paper. You also have a natural log button, so you need to make that look just like your paper as well. Just plug it in and then get your answer.